Well, thank you very much. So Ricardo asked me to talk about what the Growth Lab is doing in terms of the research agenda. So it's, in essence, the question that we have been asking at the Growth Lab is, why are some countries poor and others are rich? Which is a question that has been around for a long time. So if you look at, for instance, this is a paper by Hall and Jones in 1999 already, who asked the question, why do some countries produce so much more output per worker than others? And they have in their introduction this example of the US and Niger, where nowadays the GDP per capita of the US is $56,000 compared to only $405 in Niger. So in the data that they were looking at, they cleaned that up a little bit, and they came for 1988 at a productivity difference of a factor 35. So part of that is because the US just uses more capital per worker. Another part is because the US has a more educated workforce than Niger does. But a very large chunk, about a factor 8, is still left unexplained. And this unexplained part is what economists typically call technology. So don't be fooled by that word. It's basically the part that we don't understand about the productivity difference. So in essence, there is some kind of magic going on in the US that is much more powerful than the magic that's going on in Niger. So another way of looking at the difference between these two economies is at looking at what they actually produce. So the US has this export basket, and if you compare that to the export basket of Niger, it's much smaller. So it's about 5% in per capita terms of the US one. But not only that, Niger produces very few things. It basically more or less only produces uranium ore. So whatever it is that makes the US more productive per capita is probably also allowing it to produce so many more different things. So when we started looking at the question of economic growth, we changed this question of Hall and Jones a bit from why do some countries produce so much more output per worker to why do some countries produce many more products than others? And to understand that question, we needed to abandon the very aggregate way of looking at the economy, where basically you combine capital and labor with some technology in maybe a Cobb-Douglas function or something like that. And instead look at what does economic production actually look like in the real world. So how do you make a car? If you want to make a car, first of all, you need a technology. Right? So you need to know some kind of blueprint of how this car works. Then you need machines. And not just any machines, you need machines that can make cars. On top of that, you will need workers. So you will need labor, but not just any type of labor. You will need car engineers. And apart from that, you will need something like infrastructure to move the raw materials into your plants and also to move the finished cars to your customers. And then you might need help from some research institutes, like in Germany, the Fraunhofer Institute, which works with the car industry together to develop new technologies. And you might have some institutional challenges. So this is a very nice one, which was run in the Atlantic. Basically, the question is, what happens when we all start using autonomous vehicles and we get into an accident? Who would be liable? So in this case, we need to somehow figure out the institutional settings to make this particular industry take off. So if you want to make a car, you do not just need capital and labor. You need many different things, and actually quite specific things. To make a car, you need other things than if you want to run a hospital, for instance. So instead of thinking of capital as just one homogeneous mass, we think of it as composed of many different things. And the same for labor. There are many different experts in the labor market. And this makes production a little bit like playing a game of Scrabble. That's what Ricardo already alluded to yesterday. So the way this works is the production is a little bit like writing words in the Scrabble game, where each word requires a different combination of letters. So, and if you have all the letters that it takes, you can write a word. Similarly, if you want to produce a particular product, you will to somehow acquire all of the different capabilities that this product requires. So in one way or another, this Scrabble metaphor runs alongside a lot of the research that we're doing. So I will explain it in somewhat more detail. So in Scrabble, if you have only one letter, you can write only one word. If you have 3 letters, you can write already these 4 different words. Now, if you have 4 letters, you can write already 9 words, and the words are getting longer, right? So you can write a 4-letter word now. If you have 10 letters, according to the Scrabble website, you can write almost 600 different words. Now, this kind of logic gives you a particular development path for countries. And this is a model that Ricardo developed together with Cesar Hidalgo, which was published in the Journal of Economic Growth in 2011. So let me explain to you what this graph actually means. On the horizontal axis, so over here, you see the number of capabilities that a country has. So it's basically something like the share of the alphabet that a country owns. And on the vertical axis, you see the share of overall products that a country can produce with the letters it has. So it's something like the share of the dictionary it knows how to write. And then each of these lines is a different world. And these worlds differ in how complex the words are. So how complex is the dictionary? So for instance, if words are very short, if they only require one letter, then your production goes up linearly, right? For every new letter, you can write a new word. And that's the lines over here. But as you move to the worlds that look more like this, production becomes more complex. So think of a world in which the shortest word is 10 letters long. In that case, if you have one letter, you cannot produce anything. If you have 5 letters, you still cannot produce anything. Even if you have 9 letters, there's nothing you can produce. And if you get 10 letters, if you're lucky, you can produce a word that's actually a feasible product. Now, it's very different if you have 15 letters. Because if you add one letter to these 15 letters, you can combine that with all of the other letters that you already had, and the amount of new words that you can start writing increases super exponentially. And that explains why poor countries get stuck, because not only do they have very few capabilities, which would allow them to write only very few, very short words, they also have no incentive to acquire new capabilities. Now, one of our fellows, Andres, I don't know where he is. Andres Gomez has been using this model actually to look at the production of cities. And what he shows is that this model also explains why the most complex activities take place in the largest cities. And not only that, he figured out that this model also predicts other kinds of social phenomena. So the most complex kind of crime tend to happen in the larger cities. And also the most socially complex diseases tend to be overrepresented in the larger cities. So this is a very rich model that helps to explain a lot of social phenomena, and this was published in Nature Human Behavior last year. So another implication of all of this is that you start thinking differently about what human capital actually is. So human capital in our world is not a homogeneous mass, L, but rather composed of all kinds of different types of experts. So they are different letters. And if you want to produce something, you have to combine different experts together in different combinations to produce the specific words or the specific products you want to make. So this suggests that this letters metaphor gives you a new approach to human capital. And I will walk you through a number of implications that thinking of workers as letters in a Scrabble game has. So first of all, human capital would have to be specific, right? Otherwise, it would be a homogeneous mass. So I'll talk about that. Second, if workers are specific, they actually become interdependent. So one way of thinking of this is, imagine you are an anesthesiologist. So you went to med school for maybe 10 years. You acquired a very valuable skill. But now you end up in some place where there is no surgical team around you. So all of the skills that you have, which would usually be very valuable, are now only useful to help people fall asleep. So there's not much value to that skill in isolation. It's only valuable if you combine that with other highly skilled experts. And we'll talk a little bit about the evidence and the implications of this. And the last thing is that to become a skilled anesthesiologist, you actually have to take a lot of training, and you have to be trained by people who already are skilled anesthesiologists. So it's when you want to set up a hospital in a new place, you somehow have to get the skills there. And because skills are so tacit, because they're, as Ricardo puts it, because it's so hard to put knowledge into brains, very often if you want to move an industry to a new location, you will have to move the people, the brains themselves, to bring the skills to a new location. So let's start with the first. What is the evidence that human capital is actually very specific? Well, to look at that, we looked at Germany, in which we had access to the social security data, which covers about 80% of the German labor force. And we looked at how people move between industries when they change careers. And I'll show you here how people move out of the car industry. So people that left the car industry, they went to a number of different industries, which were in manufacturing in blue and in orange in business services. And you can see some people going here to wholesale and repair activities. So if you look at this, it seems that human capital is actually not specific at all, because people are switching all over the place. And labor economists have taken that also as evidence, this switching behavior, that human capital is not that specific to an industry. But that's actually a little bit too fast, because if you were to sort the industries by which industries absorb the largest part of these car workers, you see that the vast majority of industries don't absorb any workers from the car industry. And the ones that do are very, very concentrated. And it turns out that 50% of people that leave car manufacturing, they end up in industries that represent about 2% of employment in the German economy. And if you do that for all of the industries in the economy, the number is something like 2.8%. So that suggests that there is definitely something very specific about what people know, which allows them to be productive in some activities, but not in others. So the second part is that once you believe that workers are so specific in terms of their skills, they become dependent on one another. So my skills are only valuable in the team of co-workers that I have around me. So think again about producing a car. So I said if you want to produce a car, you need a car engineer. But that's actually not all you will need. So if you look at the Bureau of Labor Statistics, you can find that you need all of these occupations. So the car industry in the US hires over 160 different occupations. So what a firm actually does is, it has the problem that the knowledge that it requires is spread out across many different people. And if it wants to make a product, it needs to put all of these people together to cover the entire range of know-how it uses. So what we wanted to know is, does that have implications for the value of your own skills? So we looked at whether the value of your skills depend on whether or not they're complemented by the skills of your teammates. And for that we went to Sweden, because Sweden has not just social security data, they add to that, the official registries in Sweden add to that information about the specific degrees that people have in the economy. So you know for the entire population what they studied, where they work and with whom they work. So for instance, this person has a degree in animal husbandry and this person in software engineering. And these two people both have a degree in nursing, but in quite different types of nursing. So the information we have was very detailed. Now we want to know which of these skills actually complement one another. And the idea we had is that this will actually be revealed in the way firms compose their teams. Because if firms want to cover the entire skill base they need, they will make teams where workers are complementary to one another. So basically to estimate the complementarity between workers, we asked, how often do workers with specific skills show up in the same establishments? So I'll walk you through it. So let's say this is an establishment and we find workers with three types of education, so three letters, T, A, and C. That means that in this establishment, the letters T and C, T and A and C co-occur. So you can count that. And you can do that for all of the establishments in the economy. And then you get a measure that tells you how often do people with a particular set of educations co-occur as colleagues in the same establishment. And that tells you something about how complementary they should be. The problem is that many of your co-workers are actually quite similar to you, may have similar skills, so you have to clean that up for the similarity between skills. But once you do that, you get a measure that allows you to describe how complementary you are to your team of co-workers. And if you look at how that develops over time, so this is a plot of your complementarity to your co-workers as you progress in your career, so as you grow older. And you see that this goes up for over 20 years, meaning that workers sort themselves into more and more complementary teams over 20 years after they actually acquired these initial skills. What is interesting is that if you plot next to that the development of wages it actually has a very similar shape. And in the paper underlying this research, we actually show some evidence that there seems to be a causal effect of complementarity, so how complementary you are to your coworkers, on the wage that you earn. What is very interesting is that this complementarity actually not just affects your wage, but affects the value of your skills. So the value of your skills, you can think of that as, for instance, what is the premium a college-educated worker is paid in Sweden, which on average in Sweden is about 57% over primary school. So a college-educated worker in Sweden earns almost 60% more than somebody who left school after primary school, which has something to do with the fact that the wage structure is very compressed. We already talked about that yesterday, about the high degree of equality in Sweden. What is more interesting is that if you split the workers into different categories by how complementary they are to their co-workers, you see that the college wage premium actually varies a lot. You see that for people who have no complementary co-workers, they only have a college premium of about 18%, whereas people with a lot of complementary co-workers, they go up to almost 5 times as high a premium, to almost 90%. And this is true for all of the educations over a high school degree in Sweden, up to the fact that this 18% actually is more or less, so the 18%, the return to a college degree is similar to the returns to a high school degree for the average worker. So this shows that the value of a person's skills are very contingent on what the co-workers exactly know. So the last part that I want to talk about is that because skills are so specific and because it takes so long for skills to be acquired, to move letters, to move these capabilities, you very often have to move workers or teams of workers. So the way we approach this question is by asking who changes the region most. So think of Silicon Valley, right? So in Silicon Valley is a software hub, and all of a sudden it starts producing cars. And the way this happened is that an entrepreneur like Elon Musk takes the creativity out of that he finds in Silicon Valley to produce this new industry. So our question is this the normal way in which it happens, that basically creativity from inside the region creates new industries? And for that we looked again at Sweden, because, and this is work with Matteo Hartog, who's sitting over there. Because in Sweden we not only know everything about the workers that are working in the Swedish economy, but also of the establishments that exist. So we asked, when new establishments are created, are they very related to what is already there? Or are they very unrelated? Because if they're very unrelated, they will change the economy much more than if they're very related. So the first challenge is that we need to know what is related. And for this we use, again, this labor flow network that I showed you before, but we actually depict it in a slightly different way. So we depict it like this, where we use all of the labor flows in the economy, and here the nodes are industries, and they're connected if they have large labor flows among them. And as you can see, there are different clusters here. There's a machinery cluster, and there's a financial intermediation cluster. There are some business services. And the labor market here consists of sort of loosely connected clusters. What is interesting is that you can use this space because you can say, well, this is basically where Silicon Valley was, and it wants to move here. So that's a rather large distance. So we can use this space to quantify how much transformation a given actor in the economy actually produces. And we plot this in a graph like this, where you see the agents that create new activities. If they create them in unrelated activities, they will be showing up here, and if they are in very related activities, they will show up there. So here they will create transformation, here they just reinforce the existing structure. And what we find is if the establishments are set up by existing firms, they create some change, but not as much as the establishments of entrepreneurs. So this sort of goes well with the Elon Musk story. What is interesting is if you look at where these firms and entrepreneurs actually came from. So if you look at the origins, you find that it's actually local firms. When they set up new establishments, they tend to reinforce the region a lot. But once they come from outside the region, they start transforming the region. So they bring new skills and new capabilities, like the non-local entrepreneurs. And this suggests that a lot of change that is created in the economy actually comes from outside the region. And this was sort of a test case, so we're now trying to figure out how does that work on a global scale. And this is work by Michele Coscia, who's not here right now. Because we have a new data set that allows us to map the industrial activities in cities all over the world, which gives us a new type of space, and it allows us to compare the structure of London, which is service-oriented, with a structure of, for instance, Shanghai, which is much more manufacturing-oriented. And we want to ask who changes these cities most, and that I hope to be able to tell you more about next year. Another type of research that's very related, but which I will not go into because Ljubica, the one over there on the right, will actually talk about this much more, is that a lot of the letters do not just diffuse with firms, but also with the people that move. And the final type of research that we have been doing is what happens if people move only for a short time. So we have been looking at business travel using credit card payments to follow how business people travel through the world. And we have been looking at cell phone data to see how regions are connected to each other through phone calls and through the mobility of these cell phones. So we find that the diffusion of capabilities actually very often requires moving the workers and the teams. So we also find evidence for that. So that brings me to the last part. So what is this us? What is the growth lab? Who do we define ourselves to be? Well, let me show you who is working on this. So these are the postdocs that have done a lot of this research, and you can see that they have different letters. And we have people from with a background in geography, in economics, in math, in physics, in computer science. And we combine them in different combinations to produce different research output. And these people, these postdoc fellows, are actually embedded in a much larger group of research fellows who themselves come from all over the world. And they bring their own skills to the table. And this allows us actually to do these, what we think are pretty interesting and complex research products that we do. Now, our sense of us is not given by our background in terms of educational background or the field we're from. It's also not given by our nationality, but it is given by this sense of purpose that we share, that is trying to understand economic development and how economies actually move from simple to complex products. So how individuals, firms, and regions and countries in the end acquire new capabilities and use them to participate more fully in the complex part of the global economy. Now, we have a lot of skills ourselves, but that's not enough to take on such a big challenge. So on top of that, we are very grateful for the support and collaboration with a number of organizations that are shown here who are helping us achieve this mission so far. Thank you very much.